I'm Chad Severtson. I'm a service executive with InterSystems, and I had the high honor and distinct privilege of working with the Veterans Administration for the last 14 years. When I first joined the Government Support Center, the manager at the time, Thomas Slander, insisted that every time we visit a site, we walk through the front doors of the lobby. And walking into that lobby, you could really see the all that gave some. So, about a week and a half out from Memorial Day, I think it's appropriate to pause for a moment and reflect on that. But Liz, Brad, and their team have also sacrificed a lot of weekends, a lot of late nights, taking the Veterans Administration from how it's portrayed on TV to the stable, modern reality that it is today. And they're going to share that journey with you today. Thank you for your service.
How is everybody? Great.
Yeah.
You guys are way too kind. So I'm Liz Congdon.
And I'm Brad Stevens. Ooh.
And so today we're going to walk you through a little bit of the VA's journey to mirroring, to IRIS for Health, as well as our journey to the cloud. So without further ado. So everybody knows what today is, right? Today is D-Day. So with that in mind, we'll just take a moment to recognize the veterans that sacrificed for us on June 6, 1944. So today we're going to cover what the VA mission is and the scale. We're going to give you just a really high-level overview of what our journey was like. We're going to talk about how mirroring has helped VA, the challenges that we had to overcome, and then we'll offer up some final thoughts. So in 1865, Abraham Lincoln made a promise to care for him who shall have borne the battle, and for his widow and for his orphan. This was a promise that Lincoln made that didn't really come to fruition for another 65 years, and that's when the VA was formed. In 1959, the VA adopted that promise as their foundation. And today, we've just recently changed that to include families, caregivers, and survivors. So that's a broad group of people. VISTA, and we have a lot of VISTA people out here. VISTA is the Veterans Health Information and Technology Architecture, and it was developed by VA. It supports not only the veteran health record, but it also supports a lot of basic medical center business functions. Yeah, and a lot. So, you have TIU notes and you have the clinical record, and then, there's accounting, and there's inventory, and there's engineering, and all that gets rolled up into VISTA. When you look at this diagram, you can see VISTA, as the application, has its own kernel, and that kernel takes care of processing, task processing, devices like printers, HL7 messaging, and then if you move out into the pink section, you see the database itself. So that's where the actual data is stored. And then you have the software modules of VISTA that, again, I don't know if you guys can read that, but surgery, accounting, nursing, that's just a few. And then that outer ring is the clinical patient record itself. And so that's going to include things like VISTA imaging, our radiology, our CPRS, which is our GUI front end, and what else do we have up there? Clinical procedures, which helps many devices communicate with VISTA. So this data may be a little old, but we think it still applies today. So in 2014 and in 2016, VISTA was the highest rated EHR in the world. Not in the US, but in the world. And we think that's primarily because it was developed in-house by doctors largely. You can see that the VA covers about 1,300 facilities. We have about 300,000 users daily, and we're across the United States. When you start counting patient encounters, VHA in 2021 saw 6.5 million veterans. They saw them through face-to-face visits, in-house visits. They saw them through telehealth appointments. And we also have referred veterans out to the local community.
In the next few moments, we'll walk you through the VA's journey to high availability mirroring. As you can see, our journey began nearly 50 years ago. It started with a team led by Dr. John Chase, who developed a clear plan and methodology for the development of specific clinical application modules. In 1978, these initial modules were launched in 20 different VA medical centers. We could go back way during the time period and talk about when Vista was run on PDPs, other mainframe computers, as well as 486 servers at one time. But our story starts in the late 1990s. We were running Vista on Alpha servers, on their own HP's own Open VMS and digital standard MUMPs. Each hospital, all 132 of them, had their own database. So there was usually a scheduled maintenance window once a month, and depending on the site, one or two unscheduled outages. We've all been there. In 2004, the VA migrated away from DSM, or Digital Standard MUMPs, to InterSystems Caché. Caché brought to the table the performance and stability that the VA required. In 2007, there was a project began to move the databases away from the hospitals and into data centers. However, due to technological challenges, this project was halted and will not resume again into 2012. As we moved to 2010, Health Systems Engineering started working on a plan to move away from OpenVMS on Alpha servers to Linux on commodity servers. As you can see here, in 2010, this was our proof of concept. It consisted of 2 physical database servers and 3 or more application servers, or front-end servers, which were virtual. Our first site went live, or proof of concept went live in 2012 at El Paso, Texas. This was the start of a new era for the VA as far as the platform was concerned. We were moving away from the hospital module to a data center module. Also in 2012, the VA approved the project to co-locate the databases away from the hospitals and into 4 data centers. We began transitioning from managing 132 separate databases at each site to managing those same databases in 4 data centers. This migration took 6 years. Anyone knows, anyone that's in healthcare IT knows that when you're moving a hospital, it takes a sheer amount or a large amount of coordination and just planning to move it, let alone moving 132 databases. One of our challenges was user buy-in. Everyone wants to know, what am I getting out of this for my downtime and my inconvenience? We were a success of our own, we were victims of our own success. We kept Vista up, it never went down. So when we went to them and said, we're gonna have to take you down to move you, a lot of pushback. Our other challenges, as Liz showed, is Vista's not a database into itself. There's lots of interconnected devices as well as external partners. And it seemed like every hospital had a different set of devices and required some type of engineering to make it work. We standardized where we could, others we engineered around, documenting each one of them as we went through the project. To give you an idea of the scope of it, we started off slow. We migrated 1 hospital a month. We refined our processes, and we were able to move up to 2 hospitals a month. We was really just knocking it out. This was accomplished using like mini projects that were 12 weeks long. We started out with weekly calls, sometimes daily calls during those 12 weeks. Then the last 2 weeks, it was daily calls with the hospital, with the biomed, with COTS team. It was, like I said, it was nonstop. There were dedicated teams assigned to this. And those teams that were assigned to these projects, they stuck with the project, and they were physically there for each migration from the hospital to the data centers. Everything's rocking and rolling. We're into the groove of the migrations. Everything's running. What happens through any project? Murphy's Law. So we get the word, one of your data centers is closing. What? So we'd already moved 35 hospitals to that data center. Unfortunate for us, we didn't have mirroring in place at that time. So it was 35 more migrations that we'd already moved them. And they'd been in that data center for less than 2 years. Fast forward, at the same time, keeping it in mind that at the same time we were still migrating the other hospitals from the hospital to the other data centers. So lots of going on during that time period. Fast forward 18 months, we get the word again. Could this really be happening? That data center is closing, and we had 68 hospitals already moved to that data center. Pack it up, move it out. We felt like we were U-Haul. Y'all call, we haul. So, fortunately for us, we had mirroring in place at that time. And that's where mirroring, like I said, really paid big dividends. To give you an idea, we moved those 68 hospitals in 9 months with no problem.
So, there was a lot of motion, lots of things to keep up with. But in 2018, we moved from Linux clustering to a Caché mirroring high availability configuration. And that, for us, that was really, that was pivotal. But, Linux clustering is great, right? It works great. Except, at 2 in the morning, somebody has a problem, they fence a server, and now you're getting that call, Wednesday morning, 2 in the morning, hey, I was trying to fix this problem, but yeah, I fenced the server. Those are miserable calls, you guys. I mean, really. So anyway, so we moved to mirroring. Mirroring kind of solved that issue for us. I see one of our guys down here shaking his head, yeah. And it allowed us to move forward. We were able to move to an async mirror, which is our reporting mirror. It allowed us to stop managing 132 different shadows because we were shadowing for DR. We were able to stop managing those because there's a lot of management that goes into a shadow. We're able to use mirroring, the async mirroring. So for systems administrators in particular, this meant a lot of time savings, So in 2019, we moved our first 2 databases into the cloud. And I don't see anybody here from, okay. Yeah, we moved our first 2 databases into the cloud. Those sites were hosted on RHEL 6 and with Caché 2017. In February of 2020, we migrated the last alpha servers. So think about this, right? February of 2020. That was like 3 years ago, right? We migrated the last of our sites off of OpenVMS and alpha servers to Linux and Caché. Again, that's huge. It was huge. That kind of ushered in a new era for us. The old, out with the old, in with the new, and so now, things started to pick up for us. speed-wise. And that's kind of a subjective term when you talk about the federal government, because, everybody has a different definition of speed. So in August of 2020, we began upgrading from Caché to IRIS for Health. So just finished with OpenVMS, you guys. Rolled the last of those servers out the door. And now we're moving on to IRIS for Health. And so over the next year, we migrated and upgraded 98 databases. We have found that in our environment, it's easier to migrate a site to IRIS for Health than it is to do an in-place upgrade. So again, Vista is in motion. In doing it that way, we reduce man hours, we reduce the likelihood of error, and that's really key here. In February of 2020, we completed the virtualization and mirroring of every Vista database in the enterprise. In 7 years, we went from running on OpenVMS on alpha servers to fully virtualized, running on Linux, either running Caché 2017, because we're just not that good, but we're working on it. So either 2017 or IRIS for Health. 7 years. And for most people, they look at that and they're like, that took you 7 years? But here again, 132 hospitals, 132 hospital databases. Not one of those hospital databases look the same. It's the same application, but they don't look the same. So I'm kind of patting ourselves on the back. I think we did a great job. So this diagram represents what Vista's topology looks like today. We have an async mirror that serves as a disaster recovery mirror. It also serves as a reporting mirror. The async is hosted in a different region of the cloud, but it's the same cloud provider. The largest advantage of this for us is that we move a whole lot of network traffic off our TICs, our Trusted Internet Connection Gateways. So, that's very helpful because we're already busy anyway. Brad?
So as you can see, over the last 4 years, changes began to happen at a faster pace. Myriad is one of the reasons we were able to accelerate our progress toward modernization. The other, as you can imagine, is that with each successive round of migration and upgrades, we refined our processes and communications, and it's resulted in a standard repeatable process that has produced excellent results. All right. In 2012, we were transferring the entire database twice, once prior to the migration, and then once on the day of migration. What that required us to do is, because we were shadowing to keep the databases in sync, shadows and data checks were run nightly to ensure the database was kept in sync. This added a huge amount of hours and work that was unnecessary. It also introduced risks. Anybody that's used shadowing understands that data integrity is put at risk because of factors including such as corrupt journal files, network drops, and just plain human error. Moving forward to what we do today. We establish a async mirror and in our alternate location. We still have to transfer the data, but all that work can be done up front. And then on day of migration, we simply promote our, quote, DRs to be the primary and secondary. Earlier I mentioned about keeping the databases in sync. We still do that. That is done through data checks. InterSystems has its own built-in data checks. However, the VA has customized our own data checks. We've tweaked it a little bit, and it allows us to monitor the data integrity throughout the entire migration process. These data checks read the keys and values of subscript ranges and then uses checksums to ensure data connectivity between the systems. It also has a retry capability so it can be ran on live systems. We've talked about our downtime and our migration process. When we first started our migrations, we asked for 4 hours of downtime. Go to any hospital and say, hey docs, you're gonna have to do your notes on paper for 4 hours. It happened. And then following that, we had 2 hours of testing and validation, which at times, you know, you're sitting there waiting for people to call in and say, hey, you know, this is good, this is good. Now, we ask for 2 hours of downtime and it only takes an hour worth of testing and validation. And yet, to date, knock on wood, our migrations have not went past an hour and a half worth of downtime. To give you an idea, we're able to migrate 4 hospitals in one day. We've got 2 teams running. It is a long day, but like I said, I can't say enough about the teams and the people involved in that, both at the hospital and that are spread out across the country that are supporting this.
So now we're going to talk about the benefits that mirroring has brought to the VA and to Vista specifically. So it's not just migrations, right? Even though you saw the significant impact that moving to mirroring had on our migration process, time reduction, that's valuable because of the impact to the clinicians. But we also, for the first time in VA history, had true high availability. Granted, Linux clustering offered high availability, but you know, we talked about the fencing thing. You don't get to fence a mirror, right? So now you have true high availability, and the VA has never had that. Prior to that, when we were on OpenVMS, we had a form of high availability. We used a virtual IP, and we still use a virtual IP today. And we would fail, if we failed over from one alpha server to the other, we kind of held our breath and said, please, 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 hoping that that virtual IP would follow. And, I would say 50% of the time, maybe, it worked. Otherwise you're getting the call again, 2 in the morning, ring, ring. So it's again, it's the migration, it's the high availability. It's also reporting. So we were able to move a lot of workload off of our primary databases onto our async. A lot of shadows. We have a lot of shadows. There's a lot of shadowing that still occurs in VA for corporate data warehouse specifically. But we also have what are called VRO. They're Vista read-only servers that sit at each hospital. And they're there for, a good example would be like a WAN isolation. If you had a WAN isolation event, you could still see patients with up-to-the-minute data. All of that got moved off our primary mirrors and onto our async. Yeah, so I just covered this slide all at once. But you can see here the mirror with the async and then talking about read-only. So finally, mirroring really impacted our operations staff in a great way. And that is, we have no downtime anymore, at least for OS patching. Our operations staff patch the B mirror, whichever is not the primary mirror. So they patch the secondary mirror, fail over to it, patch the primary mirror, and users don't even know it's happening. They don't even know it's happening because there are no drops. It's seamless. That change has basically moved us to having one major downtime a year. And that's usually for an IRIS upgrade. And I'm going to tell you, even though it's like one downtime a year, we still have to fight with the site to get that downtime. So, Brad?
So, continuous technology changes have necessitated the engineering of a more stable and robust environment. We work closely with our intersystem partners to successfully implement mirroring. Mirroring is just one of our stories and steps toward Vista modernization. Challenges, there's always challenges. We'll talk a little bit about Vista in the cloud and some of their topology. As we spoke about before, as I spoke and Liz spoke about, all the interconnected devices, as well as our external partners that tie into our database and have to connect and transmit data to the database only via an IP only, not fully qualified domain name. Put on our thinking hats and said, okay, what can we do to fix this? So we came up with a virtual IP. Works great on premise. No problem. Everything's rocking and rolling. It's great. Mirroring's fine on premise. And that's because on premise, our A node or our primary member and our backup member, they sit in the same subnet, in the same data center. Virtual IP has no problems following the failover from one node to another. Moving forward into the cloud, guess what? Our primary member and our secondary sit in two different availability zones with two different IP subnets. Virtual IPs don't work so well like that. Back to the drawing board. So what did we came up with? The F5 load balancer. We allowed it to manage the traffic. It determines which one is the primary node and redirects the traffic that's trying to speak to the database to it. And there again, the users are none the wiser that we failed from one node to the next. The other is training. Our operations staff, and we've got a few in here, they're great. But moving with any new technology and any different new environment always presents interesting challenges. We had to make sure that they had the tools to actually continue to operate at the level that they do. This could not have been achieved without the help from our intersystem partners and our own internal VA cloud team. There's a lot of online material that's available and also help desk, or as we call it, service desk, that we can log tickets and talk to them. And they're never too shy about picking up the phone and calling somebody. And they're always on the other end to say, hey, how can I help you? The third challenge is basically there's non-mirror aware local elements at the %sys namespace in Vista. This includes such things as local security accounts, web applications, and services. During the failover, we've developed scripts that exports those services over from one node to the next node, and the end users there again, they're none the wiser that things are happening in the background. Don't pay attention to what's happening behind the curtain. So.
So we'll wrap it up. I know that was kind of quick.
Sorry about it.
Sorry about that, but we'll just do a really brief recap. We expect to have every Vista database in the cloud by June 2024. We'll be working every other weekend until then. It's okay. It's okay. I don't even know what I was going to say here, sorry. I'll just move on. So just real quick, the VA is one of the largest healthcare organizations in the US. And like I said, 300,000 plus users, probably more than 6.5 million patients now. Our challenges continue. We continue to have challenges. But one thing that we have been able to do is produce probably the most robust and stable platform that Vista has ever run on, using Linux and IRIS for Health. We couldn't have done that, though, without having some exceptional engineering folks on our teams. Dedicated, and really just great guys and gals. So yeah, that's kind of how the VA got to mirroring, and how we'll continue to move forward. Questions? Sure.
Moving from your current environment to the new platform, sort of what kind of logic or business case did you go through in order to arrive at that decision?
Okay. That's a lot of information.
Let's take the easy one.
Well, no, so yeah, we are moving to the AWS cloud, Amazon Web Services. In terms of the logic process and the steps that we took, that's a little more complicated. So a lot of this was a lot of this development, a lot of this engineering took, like I said, took place over a 7-year period, and so it became a process of steps. What is the next logical step? And so understanding the platform and understanding what the needs of the customer were paramount in making those decisions. Vista itself is very monolithic. I mean, let's face it, let's be honest. Vista is an old piece of software.
That has been updated every year.
Every year it gets a little bit better. And so you have to understand that and then make those decisions. That's kind of why we chose a migration process in the first place versus upgrade in place. Because for the application itself, it just worked better.
I can tell you that one of the factors, including as far as choosing a cloud provider, is with anything, is performance, disk performance. Our current provider offers the disk performance that is required for Vista. There's others out there that, as they move forward, we'll explore them. Like I said, we're not locked into one provider, and we're not a spokesperson for any of those. But it goes back to performance and what's available at that point in time. So.
Is there any particular reason you decided on Amazon versus Azure? Was there any?
Right.
You might repeat
So,
the microphone.
Sorry. Was there any particular reason you arrived at the decision of Amazon versus Azure?
that is actually one of the reasons, is performance.
Okay.
Because Azure does not, I can speak to that, and this is data that is constantly changing, so if it changes tomorrow, then I'll be wrong, but when we made that decision, they didn't have the IOPS needed to run what we needed in a timely manner.
Other questions? Sure.
Please wait for the mic. And can everybody hear us okay? Yeah. Okay.
So you guys spoke a little bit about the data check being a little bit different that you guys use, that you made some change to InterSystems data check. I mean, you don't have to speak about it, but I guess I was just curious, you know, if you would speak about it. I guess that's what I was wondering. Thank you.
So I think we would if we actually could.
Okay.
So Brad and I are not the technical, we're not the technical part of this operation. And the person that actually made some of those minor changes is not here with us today. So
We'll be happy to get with you.
Absolutely.
Just after we'll get your information and get back with you on that. It's nothing magical or nothing proprietary. It's like with anything, it's any changes that can be made. So we didn't go completely off the rails or off the reservation changing things.
I think there was a question here.
Wait for the mic, please. Okay, my question was, even though we're in the cloud, is the government data somewhat separated from like private corporation data?
Absolutely. We are in what's called FedRAMP High. It's one of the highest levels of security that is available at this time. I can assure you that for our ATO, and we've got our system steward in the crowd here, for our ATO, it is a very rigorous process, and security is at the highest level. If you're a veteran, no, you will not hear about our data leaking out from the cloud. There may be other breaches through human phishing, things of that nature, but by it being in the cloud, that's nothing you have to worry about.
Any other questions? All right, well, thank you very much for your time today, guys.